A long queue of people waiting impatiently at the takeaway. Sadly, it's nothing out of the ordinary. You can't serve everybody at the same time. To make things worse, probably half the people in the queue are only there to collect their deposit on a plate or drinking cup. That's the way it goes with returnable products. Although not ideal, one solution is to use non-returnable catering dishes, but sorting waste is a costly exercise and it's difficult to remove impurities. They eat their way into the material and contaminate it. Not only does this make recycling uneconomical, for foodstuffs it's useless. Non-returnable dishes may provide logistical advantages, but convincing recycling concepts aren't in place and they are frowned upon by the authorities. So instead, we end up burning the waste to generate energy. The only usable part of the waste is the energy we get back from the crude oil, at most 20 megajoules per kilogram of plastic. The materials as well as the processing energy are wasted. Recovering plastics is a highly intricate process, not to say expensive. The impure end material can only be downgraded and used in inferior quality products. Of course, this also contradicts the aims of regrowing raw materials. But that's enough of the theory. In practical terms, the answer to long queues, piles of rubbish, and energy wasted on incinerating degraded materials is to make catering dishes out of Belland material. Belland material is an innovative state-of-the-art material combining the ecological benefits of reusable materials with the commercial benefits of non-returnable materials. Its beauty lies in the way it conserves valuable resources, saving time and money. No need to sort plates, cups, knives and forks anymore. Simply put them in one machine and recycle cost efficiently. Here you see a glass model demonstrating how the machine works. First of all, any remaining grease and food is washed off. Next, a 1% alkaline solution is added. Under these conditions, the Belland material breaks up into individual polymer chains. At this point, you could compare the process to paper recycling. In energy terms, this prevents wastage of the energy contained in the material and of processing energy. At this point, the Belland material has been completely dissolved. Sieves, filters, and standard water purification processes then extract the Belland polymer chain completely from the base, returning it to its purified molecular state. The Belland material once again adheres to the strictest quality and hygiene standards. Here you see liquid Belland material passing through a filter. Now all that remains is insoluble plastic and other residues. Paper fibers have been filtered out for use in paper manufacturing. The process even allows you to separate out dyes. By adding a weak acid solution, the valuable material, the pure polymer chains, coagulates, creating so-called Belland flocker. The recycling process is now complete. Once the machine has drained the Belland material off, it is ready once again for straightforward processing. A whole chapter of the Factor 4 report laid before the Club of Rome was dedicated to this groundbreaking technology. Going by the full title, Factor 4, Doubling Wealth, Halving Resource Use, the report concluded that this was an impressive demonstration of a resource-conserving recycling process. Our closed-loop recycling process can be easily integrated into existing paper recycling setups. What more could you ask for? New and innovative technology working in perfect harmony with traditional tried and tested paper recycling systems. It's worth taking another look at the energy part of the equation. As a rule, approximately 40 megajoules of basic energy and 50 megajoules of processing energy per kilo are retained within the system. Belland Flocker forms the basis for further processing, providing pure materials for making new Belland catering dishes. The recycling process requires less than 10 megajoules per kilo. This is the way the authorities and consumers really imagined closed-loop materials management would work, and this is the way trade and industry intended it. Catering dishes made from Belland material combine the ecological benefits of returnable dishes with the economic benefits of non-returnable dishes. Catering dishes made from Belland material, the trademark of ecologically sound and commercially viable closed-loop materials management. All round, a superior alternative. An alternative you could be tapping into today.